All right, hopefully there's no weird audio glitches this time. Hello everybody. I decided to redo my gameplay programming series because after a bit of time you always look back at your old stuff and you're like, okay, I can do better. The software entropy that I ran into where the code was starting to get unmaintainable, there are probably better patterns that I can apply. I'm going to be splitting this into little chunks, little bite-sized chunks. And the first one of these is transformation systems. So ever since I played the first American McGee's Alice game in 2001, it had a feeling of being Turing complete in the sense that you've got really cool textures, really cool environments, you've got colored lighting, and most of all, you've got these dynamic objects which can move around in free space, and it was just really cool, and I felt like that was the peak of transformations. It was the peak of freedom, really. 2001, what a wild year. But anyway, so previously I was implementing a third-person camera in my gameplay programming series, and here's how I was doing it. Basically, I started with a camera and a player, and I made sure that I created the camera at some initial position which was nearby the player. Then every frame, according to the mouse movement, or player movement, the camera would move according to its local vectors. That's the forwards, right, and up vectors. And then every frame after moving the camera, it would recalculate its frame of reference. In other words, it would recalculate its fundamental vectors. And this action of moving a little bit on your right vector, but then turning around to face the player, and then moving again on your right vector continually, did a pretty good job of approximating circular motion. But there are some problems with this approach, or rather, some limitations. And that is, okay, so it's fine if we start the camera from an initial offset, but what if we want to change the offset? Or what if we want to look at a position which is a little bit off from the player? So we're not looking at the player, but we're looking at a little bit to the right of the player. For instance, if we're looking over the player's shoulder. Now, there are ways to approximate that, but they're a little bit janky and they're hard to maintain. There are some other approaches that we can take, two of them mainly. There's a transformation hierarchy, so you can have objects which depend on other objects. If you have a child object which depends on a parent object, it can calculate its local transform and then afterwards apply the parent's transform. And then another approach we can do is called sockets, and this is how Unreal does its skeletal animation system, basically. So the parent object has some number of fixed positions and orientations that it keeps track of as it animates. So for instance, you could have a model and you know where your right hand position and orientation is. And then when you slot on a child object, it takes the orientation and position of that socket. So for instance, you can swap out any gun and it will just fit into the right hand as you would expect. So the approach that I'm going with is sort of a hybrid of these two. It's sort of like sockets, except that the camera, the player object isn't going to keep track of the sockets. It's actually the camera is going to manage that. And it's sort of like a transformation hierarchy in the sense that we calculate the camera's transform and then bolt on the player's transform, but not quite, because the player could be looking a different direction to the camera and we don't want the camera to spin around. But I think I've done enough teasing of this, so I'll just go on to the solution. So the solution is basically three transformations. On the left here, we can see the starting, the starting offset for the camera. So we have that hard-coded, that's some vector, vec3, and it undergoes two transformations. We have T1, which is basically the altitude transformation, that's a rotation around the y-axis. And then after applying that, we apply T2, which is a rotation around the z-axis, that's a horizontal plane rotation. And then finally, we want this camera to be centered around the player. So we apply T3, which is a translation basically to the player's position. So we can see that on the right. And the really cool thing about this is we can actually apply this to multiple things. So we can have an arm or an armature for the player, and then a look target which is some offset of the player's position. So this lets us pretty easily look at points which are not directly at the player. But anyway, let's see that in action. All right, so here we are in the code. Let's have a look at it first of all, check that it's working. Boop, there we are. Now I've just put us in the corner here so we can see our motion. Now if I move the camera around, we are in fact moving, and we can zoom based on the arrow. So if I left click, here we're zoomed out and the player is the center. If I right click, we're zoomed in and we are just set to the right of the player. So we are basically resetting our armature with every zoom, and we can verify that, yep, that's left, right, forwards, back. And if we go around in the other direction, left, right, forwards, back, like we'd expect. And this is a lot of fun. But yeah, right click, we're offset, ready to look down our sights and shoot. Left click, we're back as normal. The next question is, how do we animate this zoom? Well, that'll be for a future video. But let's have a look at the code. So just like I was saying, I'm using this transformation system. So this is all set up. Code will be provided. I don't want to step through the irrelevant stuff, so we'll just keep to it basically. So like I said, we have T1. The first thing we're doing is rotating around the y-axis. Okay. And then we're going to do T2 and we're going to stack that on. So we're going to keep that original transform and then multiply on a second transform, which is the horizontal around the z-axis. And then finally, we're going to keep that original transform and then multiply on a translation to the player's position, basically. Excellent. So then in order to use that, we'll have two things. I've got these variables, I'm calling them arms or armatures. We have a near and a far. Now in order to, what am I thinking? We're going to need two things. We're going to need the camera's position, the offset from the player, and the point that we're looking at. So first of all, we'll take whatever our arm variable is, it's one of those two, and we'll send that through the chain of transformations, and then we'll read that back as our position. And then similarly, we will basically take an offset just in the Y and at the same height as the player. And this is really just a hack because, well, the point is I should be able to plug in any vector at all and transform it. And this is the point that we're looking at. So we then set that as our target position. And then go through the usual cross product methods. So there we have it again in action. Here we are in shooting mode, adventuring mode, shooting mode, adventuring mode. And then, yeah, future video will be actually getting that nicely smooth, nicely animated. But yeah, anyway, have a good one, and I'll see you again soon. Bye.